Good afternoon, everyone. I'm Sadhana. I'm working assistant professor in Department of Pharmaceutical Engineering, BVRIT Narsapur. On previous class, we discussed about the introduction of biotransformation and different phases in the biotransformation. So, in today's class, we'll discuss about phase 1 biotransformation. What are the enzymes involved in the biotransformation? So, what are the mechanisms involved in phase 1 biotransformation to convert the drug into metabolite? In the biotransformation, we have mainly two phases of biotransformation. So, phase 1, which includes oxidation, reduction, and hydrolysis reactions. So, these phase 1 reactions are mainly used to convert the water insoluble component to water soluble metabolite, so which is easily undergo the phase 2 conjugation reaction. So, the phase 2 reactions are main biotransformation reactions. In this, these enzymes directly convert the water-soluble component to non-toxic component, which is excreted through urine directly. So, the phase 2 reactions includes the sulfate conjugation, glucuronide conjugation, glutathione conjugation, and amino acid conjugation. So, all these conjugates are freely soluble in water and they can easily excreted through urine. So, in phase 1 biotransformation, we call these reactions also as functionalization reactions, because in this, the functional group in the drug, which is water insoluble nature, is converted into water soluble forms like OH groups and carboxylic acid groups and amine groups, and these water soluble components is directly undergo to the phase 2 reaction for detoxification of different varieties of drugs. So here the attachment of functional groups like OH, COOH, NH2 happens. So metabolite may be converted into inactive form, or the metabolite is still in active form only, but it is water soluble form. So next, the conversion of more hydrophilic nature of the drug molecules. So actually the drugs which are lipid soluble and water soluble in nature. So in this phase 1 reaction, whether the drug is water soluble also, it is again converted into more hydrophilic and highly water soluble, and it undergoes to the glutathione conjugation. So the examples of different varieties of drugs which undergoes phase 1 reactions are, so for oxidation, the phenytoin and barbiturates, which are prone to phase 1 and convert into water soluble compounds. For hydrolysis, the drug aspirin, so undergo the hydrolysis reaction in phase 1 biotransformation, and it is converted into water soluble form. And in the reduction reactions, benzodiazepines, so these are the main components which are used for the cerebral diseases. So these benzodiazepines converted into water soluble compounds in the reduction in phase 1 metabolism. So this is the main steps involved in the phase 1 metabolism. Here the RH component, mean to say the compound which have the hydrogen bond, which is converted into ROH. So that OH is a water soluble group by using this NADPH. So this NADPH is converted into NADP plus. So here one molecule of water was released, and the component which is in lipophilic in nature is converted into hydrophilic nature by adding this OH group. So this is the mechanism involved in the phase 1 biotransformation. So phase 2. So what is phase 2 biotransformation? So these are called as detoxification reactions, because if any drug undergo the phase 2 biotransformation which lost the biological activity of the compound. So that's why we call it as true biotransformation reactions. So these endogenous polar molecules is conjugated as like carbohydrates, amino acids like glucuronic acids and methyl GP and sulfate and glycine conjugates. So here already in phase 1 reaction, many drug substances are converted into water soluble compounds. These water soluble drug substances again conjugated with different components like glucuronic acid, methyl GP, sulfate and glycine. So all these conjugates were highly polar in nature, and these conjugates are detoxified and the inactive water soluble components are excreted from our body. So here the converted to hydrophilic and pharmacologically inactive compounds. So the compounds, if in case of any first pass metabolism, some of the drugs which we called it as prodrugs is converted into active molecules. So like this, if any drug is polar in nature but it is active in the phase 2 metabolism, so these active components are converted into inactive components by conjugation reactions and excreted from the body. So the glucuronic acid conjugation examples are paracetamol and chloramphenicol. So these two drugs are undergoing the phase 2 biotransformation and the inactive components are excreted from the body. So phase 3 metabolism. So till now we discussed about two types of metabolisms. One is phase 1 and phase 2. So which are main for the detoxification of any compounds like xenobiotics. What are the external compounds which are entered into the body? Say for example, if we consume any fruits, any vegetables, any pesticides residues are present on the substances, also called as xenobiotics. By using these two transformations in the liver, these materials are converted into detoxified components. So if any component is reversible in phase 2 reaction, say for example the toxicity of conjugates to various cell components. So if in the conjugation reaction any glycine glucuronic acid conjugation which produce any toxicity to the cell substances, so by using phase 3 metabolism the body can detoxify the components. And hydrolysis of conjugates back to the original reactive species, mean to say, so any component which is converted into a conjugate, if it is reversibly converted into original compound, this phase 3 metabolism blocks the conjugation reaction and which leads to detoxification of the compound. So, and inhibition of phase 2 enzymes. So, any drug substances after metabolization, the metabolites will kill or inhibit the phase 2 enzymes. By using phase 3 metabolism, we can reduce the toxicity of such type of compounds. So, an array of multi-purpose membrane-bound transport system, which we call it as proton GP and P-glycoprotein enzymes, which are activated in the phase 3 metabolism and inactivate the compounds which we discussed above, as like the toxic conjugates or the metabolites which are inhibits the phase 2 enzymes and the conjugates which are reversibly converted into the original reactive species. All these three types of compounds are deactivated in the phase 3 metabolism and excreted through the body. So now till now we discussed about different types of phases in the metabolisms. So now we'll discuss about phase 1 and phase 2 enzymes. The enzymes which are responsible for the metabolism are we are discussing now. So phase 1 enzymes which includes the cytochrome P450, monooxygenase and flavin containing monooxygenase which we called it as FMO, and esterases and alcohol dehydrogenase, aldehyde dehydrogenase and monoamine oxidase. So in this different enzymes is working for different reactions. Say for example oxidase is working for the oxidation reactions and hydrogenase is working for the hydroxylation reactions and other reactions. So all these enzymes included in the phase 1 enzymes because the reactions which was happened in the phase 1 metabolism like oxidation, reduction, hydrolysis are catalyzed by these enzymes. So the phase 2 enzymes are uridine diphosphate glucuronosyl transferase UDPGT and sulfotransferase and N-acetyl transferase and glutathione S transferase and methyl transferase and amino acid conjugation. So all these phase 2 enzymes are involved in the phase 2 metabolism. So see here, this is the CYP450 oxidation reduction cycle. So the main enzyme which involved in the phase 1 reactions are CYP450, mean to say cytochrome P450. So how this cytochrome P450 organizes the oxidation reduction cycle and how it convert the RH, mean to say the compound, so which is lipophilic in nature, is converted into ROH, which is hydrophilic in nature. So here what are the reactions involved in the oxidation reduction cycle? So the first one, see here two types of proteins So first one is a heme protein cytochrome 450 which contain terminal oxidase used to conversion of RH to ROH. So this is the heme protein cytochrome P450 which is used for the conversion of RH to ROH. Here R is the component and OH is the functional group which is water soluble in nature. So the second enzyme flavoprotein known as cytochrome P450 reductase, so which is used for the NADPH dependent. See here in the steps 2 the NADPH was used for the transfer of electron in the reaction. So like this, these two enzymes, the first one the heme protein cytochrome P450 which contain the terminal oxidase. So this oxidase is used for the oxidation reaction, and the second one flavoprotein known as cytochrome 450 reductase. So this reductase is used in the reduction reactions. Like this cytochrome P450 oxidation reduction cycle continuously keep on going, and which converts the water insoluble compounds to water soluble compounds. So now we will discuss about the cytochrome P450 oxidation reduction cycle. See here, first one, the heme protein which contain Fe3. Mean to say? So this is the heme protein. So by the addition of one electron from the NADPH, it is converted into Fe2+. So in this reaction, this RH, what is the substrate which we would like to detoxify? Mean to say the drug molecule, any. So which we would like to involve in the phase 1 reaction, which comes and bind with cytochrome P450. So later on, the binding of oxygen to the heme protein. So here from the above conjugate, so oxygen was attached which forms ternary complex. So after that again one more electron, so the transfer of second electron reducing dioxygen to a negatively charged epoxy group. So by the addition of another electron, this oxygen, see here there is no charge. So by the addition of electron, it is converted into negatively charged, which is a peroxy group. So this peroxy group is highly reactive. So immediately here it will produce one water molecule. The peroxy group is rapidly protonated twice, releasing one molecule of water, forming a highly reactive iron, which is called oxo species. So immediately this peroxy group, whichever it formed by addition of one electron to the component, immediately it will react and it will release one water molecule. Again it will convert into highly reactive iron oxo species. So from this, so it forms a bond with oxygen and ROH group was eliminated. Mean to say the component which is attached with OH group. See, the RH in the active site reacts with highly reactive iron, which is nothing but oxo species, and releasing a hydroxylized product. So here what is the hydroxy group? OH is the hydroxy group. So release the hydroxylated product. The enzyme returns its original state. See here. Here again the same enzyme was replaced and another RH molecule was attached to the enzyme. Again the oxidation reduction cycle will happen. So like this cycle will continue and the cycle used to attach the hydroxyl group to the compound. So this is about the oxidation reduction cycle which involved in phase 1 metabolism. So now we will discuss about different mechanisms, mean to say oxidation, reduction, hydrolysis in phase 1 with examples. See, first one, oxidation. Oxidation means addition of oxygen or removal of hydrogen. So the oxidation by cytochrome P450 enzymes is microsomal mixed functional oxidases. So we already discussed the oxidase enzyme which involved in the oxidation reactions. So this oxidation reaction by cytochrome P450, so the oxidation of alcohol is done by alcohol dehydrogenase, and the oxidation of aldehyde by aldehyde dehydrogenase, and dealkylation by monoamino oxidase. So these enzymes are involved in the oxidation of different types of compounds like alcohols and aldehydes and dealkylation reactions. So the drugs which are involved in the oxidation reaction are phenytoin, barbiturates, propranolol and imipramine. So these are the different types. Many more drugs are there. So these are the few examples of the drugs which involved in the phase 1 mechanism oxidation reactions. So these are the different pathways in the oxidation in phase 1 reactions. So first one is oxidative reactions. So all these reactions main motto is attachment of a water soluble functional group, whether it is a hydroxyl group or it is a COH group or it is amine group. So whatever the group attached to the drug molecule should be soluble in water. So here see, in the N-dealkylation, so alkyl group was removed. So that's why we call it as dealkylation. And see here, NH2 group is attached, which is amine group is attached to the drug molecule, which is water soluble in nature. So these are the examples like imipramine, diazepam, codeine, morphine, etc. All these types of drugs involved in the N-dealkylation reactions. Next, O-dealkylation. In N-dealkylation reaction, what happened? Nitro group, which is nothing but amine group, is attached to the drug molecule. In O-dealkylation reaction, same, that alkyl group was removed out from the drug molecule. See here, this is the group removed from the drug molecule, and here it is O-dealkylation. That's why OH group, hydroxyl group attached to the drug molecule. So next one, aliphatic hydroxylation. So here, see here. So for this hydroxylation, one OH molecule is attached to the drug molecule, which increase the solubility of water. So the components like tolbutamide, ibuprofen and phenobarbital and cyclosporins and midazolam. So all these types of compounds which involved in aliphatic hydroxylation and convert into water soluble molecule. So next, aromatic hydroxylation, mean to say the components which is attached to the benzene ring, aromatic ring. See here. So here this component convert into water soluble molecule by the addition of OH group. So next, anoxidation. So see here, nitro group, so which undergoes the oxidation and it form NHOH, which is a water soluble component. Next X-oxidation. So N-oxidation means nitro group is converted into water soluble group, means the OH is attached to the nitro group. S-oxidation means sulfur. The sulfur undergoes reaction and it forms oxide group. And deamination. So deamination means amine group was removed from the component. See here, this amine group is removed and compound was formed with high water solubility. So examples are diazepam and amphetamine. So like this, all oxidation reactions was used to attach any carboxylic acid group or hydroxyl group or amine group to the compound. So based on the chemical moiety which is present on the drug molecule, different reactions happens in the oxidation cycle. So next, reduction reaction. So as we already know, the reduction reaction means addition of hydrogen or removal of oxygen. The substrates from the reduction reactions include azo, nitro compounds, epoxides, heterocyclic compounds and halogenated hydrocarbons. So azo group, nitro group and heterocyclic compounds and halogenated compounds. All these components undergo the reduction reaction and it is converted into water-soluble compounds. See, azo group and nitro group reduction was done by cytochrome P450. Carbonyl mean to say aldehyde or ketone. Aldehyde means CHO. Ketone means C double bond O. So all these carbonyl reductions done by aldehyde reductase, aldose reductase and carbonyl reductase and quinone reductase. So here see, in last slide we discussed about the oxidation. All the enzymes are oxidases and dehydrogenases. Here all the enzymes are reductases. So which participate in the reduction reactions. So different types of drugs like chloramphenicol, warfarin and halothane and chloral hydrate, all these drugs undergo the reduction reaction in the phase 1 metabolism. So see here the examples. So first one, reduction of aldehyde and ketone. See here, ketone group. So which is present in the warfarin. So this ketone group reduced to form hydroxyl group. So it is a water soluble component. And in the second example, methadone, by attaching OH molecule to the compound, it reduced the methadone. So these are the two examples for aldehydes and ketones reduction. Next, reduction of azo and nitro compounds. So here in the nitro compounds, initially it is converted into nitroso, later on hydroxylamine, then amine was released. So previously, we discussed about the deamination reactions. Here NH3 group was released, which is nothing but amide group was released from the components. But here, so the amine group, primary amine group released from the component. So this is the mechanism of the reduction of nitro compounds. The nitro compound, first it is converted into nitroso compound, next it is converted into hydroxylamine compound, later on it is converted into primary amine. See here in the example, the nitrogen formed in O2 group. See here, the nitro group, which is converted into NH2 group. So in the intermediate, all the above steps what we discussed, the conversion of nitroso group and the conversion of hydroxylamine group was formed. So here the directly we saw the change in the drug molecule. Here the nitro group was converted into primary amine group, which is water soluble group. So next, hydrolysis. So we have two types of the hydrolysis already we discussed in previous subjects, ester hydrolysis and amide hydrolysis, cleavage of, which is nothing but the cleavage of water molecule. See, one ester plus H2O, by the addition of water molecule, it is converted into acid and alcohol. So many of the drugs with esters, ethers, amides and hydroxides undergo the hydrolysis. So different drugs like procainamide, aspirin and pethidine. So these are the different examples for the drugs which are undergo the hydrolysis in the phase 1 metabolism. All these type of drugs undergo the phase 1 metabolism and it releases either acids or alcohols. See here some examples. Hydrolysis of esters and amides. See here, aspirin, so which has ester group, is converted into salicylic acid and acetic acid. So as we already discussed, when any ester is react with water molecule, it will release acid and alcohol. So in this reaction, acid was released. Here one is salicylic acid and another one is acetic acid. See here in the procainamide, amide group, CONH group is breakdown into COOH and NH2. So which is nothing but para-aminobenzoic acid and 1-amino 2,2 dimethyl amino ethanol. So here one alcohol formed and one acid formed. So these are the two examples for hydrolysis reactions. So that is about the phase 1 reactions, which different types of drugs was involved in oxidation, reduction and hydrolysis, and it is converted into water soluble molecule which undergoes the phase 2 metabolism. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.